We're looking today at strings and pulleys. And really, in a pulley system, what do we have? We might have some mass M1 connected by a string over a frictionless pulley, and we might have some mass M2 hanging over that pulley. So generally, we have these two masses connected by a string, and generally the system is free to move. Basically, however, that it would like. The goal of the problem usually is to determine the tension in the string. And this will usually help us problem solve any type of string and pulley question. And when we do this, there are some assumptions that you can make to complete questions. The first assumption that we can make is that our strings are considered to have negligible mass. And from that, we assume that there's only pulling forces going on. In other words, the strings only contain tension force. Our second that we can assume is tension is constant throughout the string. Our third that we can assume is that our frictionless pulley might change the direction of the string but does not affect the tension of the string, which is big there. That means that we can just concern ourselves with the magnitude of the force. We don't need to worry about the direction. Let us assume that strings don't stretch and that objects attached by pulleys accelerate the system. And last but not least, what we can assume about pulleys is that the direction of motion is always positive. There's the assumptions that we can make, and this helps us actually solve various string and pulleys questions. For example, if I have a 3 kilogram mass on a frictionless table attached by a light string, and that string is negligible mass, and it's attached through a frictionless pulley to an 8 kilogram mass, we can determine the tension and the acceleration. So let us think about this. We have some table with a frictionless pulley that has a 3 kilogram mass attached to the pulley, and hanging over the table is some mass of 8.0 kilograms. So we can assume that the acceleration is going to be going to the right and downwards as our positive direction. Therefore, we can analyze the motion of each mass, similar to what we did a couple of days ago. For mass 1, we see that we have our 3 kilogram mass, and what are the forces acting on this 3 kilogram mass? Well, since it's in contact with the table, we clearly have a force of gravity and our equal but opposite in direction normal force. We do have our tensional force from the string going in the right direction, in our positive direction. And we will notice in this case that acceleration is only moving in the direction of motion, so we only have an x component that we need to focus on as we develop our solution in this case. And that tells us that my net force, or our net force in the x direction, is equal merely to our tensional force, which by Newton's second law is the mass of our first object and our acceleration. And we're going to use this fact in 1 second. If I think about the motion of mass 2, my free body diagram, we have some tensional force in the upwards direction, and we will also have the force of gravity acting down on our 8 kilogram mass. And remember in this case that our direction of positive and acceleration is going down. And this only has a y component. So this will be our force of gravity minus our tensional force in the mass, which is equal to our second mass and our acceleration. Well, let's see what this gives us. We had an equation. We can substitute m1a for our tensional force now. And our force of gravity in this case is going to be m2g. So what does this give us? m2g minus m1a is equal to my second mass, m2a. So, mass of 1, let's make some substitutions finally. So this will be 8.0 times 9.81 minus 3.0a is equal to 8.0a. Basic solving equations now, which we are all very good at. This gives us 11a is equal to 8 multiplied by 9.81, which for some reason I did not do, but I do have my answer. Divide both sides by 11. And we see that our acceleration in this case is 0.7272. And simply to calculate our force, now let's go back in here of our tension will merely be 3.0 times 0.7272, and that is 2.1818. Therefore, our tension force is 2.2 newtons, and acceleration is 0.73 meters per second squared. There's just reviewing a string and pulleys question just to help you out in case needed for question number 4 in section 2.4, I believe it is.